22 for week 20. Let's take a look at our question. The expression 4x squared plus bx minus 45, where b is a constant, can be rewritten as, we can see it's in factored form here, hx plus k times x plus j, where h, k, and j are integer constants. Which of the following must be an integer? So how did we do on this one? Looks like we did fairly decently. 67.5, just shy of the 70% mark, said that it was answer choice D, which is in fact the correct answer. And the other ones are just kind of split between, obviously, the other three. We said that this was medium, skewed a little bit towards the harder side. As far as this question goes, it does involve factoring. Factoring tends to be one of the tougher things to do in algebra, and especially when you throw in some variables here, some extra variables, the h, the k, and the j, that does amp up the difficulty a little bit. So what this one involves essentially is just factoring. And actually, factoring as foiling backwards. And that's exactly how I'm going to start this thing, is I'm going to take this hk plus, that's hx, plus k times x plus j, y, okay. And then I'm going to FOIL this thing out. And when I'm done, I'm just going to match it up with the quadratic that they gave us and see where we can take it from there. So first, we'd have h times x gives us hx squared. Okay, and then our outside terms, hx times j. I'll just put these things in order with the x value last here. So there should be a plus on here. So plus hjx, okay. Our inside is kx. And then finally, our last terms here, plus kj. Okay, so now what I'm going to do is I'm just going to match up it's called equating the coefficients, essentially. So if I write this down right underneath it, the one that they gave us, it would look like this, 4x squared. Just pause for a second. This tells you something about what h is, if you needed that information. I don't know. We'll see. Okay, and then the next term here is plus bx. Now this one's a little trickier. The way that you would get what b is actually equal to in terms of the other parameters here is that all of this stuff, let's make this green here, is equal to what bx is. If I were to kind of write this out, this would be hjx plus kx is equal to bx. And you could divide by x. I'm not going to do that. I'm just going to like pull this out distributive fashion. So I'm going to pull this x out of a set of parentheses here. I'm actually going to put it on the right-hand side. Super unconventional. Hj plus k would be equal to bx, which means, what are we doing green here? All of this would be equal to b if I needed it. Turns out I don't. The part that I actually need is this last bit here, which is minus 45. So minus 45 is exactly what k times j is supposed to be equal to. Here, let me write that also as an equation. So I have kj should be equal to negative 45. And the negative part can kind of be ignored, especially since you look at these answer choices, there's no negative here. But remember what it told us about k and j. It says k, j, and along with h, these things are all integer constants. And I'm taking these two integers here, and I'm multiplying them together to get negative 45. They got to be the factors of 45. You know, it's something like 1 and 45, 3 and 15, 4 and 9. It's something like that, right? So notice also what our answer choices look like. And I think I can make one of these things happen. I can make that answer choice D happen by just dividing this kj by k. I'll divide the k over here to the other side. So what this equation is telling me What this equation is telling me is that if I divide 45, or even negative 45, doesn't really matter, if I divide it by k, which is an integer, because it told us that it was an integer coefficient, I get j, which is also an integer. And so if you know anything about FOILing and factoring and stuff, maybe you could have jumped right straight to that conclusion that if I multiply the two last terms together, I'm going to get the constant term of negative 45 here, which means that I'm going to use those in order to figure out which of the following must be an integer, which brings us to answer choice D. And I think the rest of them were just kind of roughly evenly split as far as our results go between the other three, possibly as guess. Now, if I look at this last one here, 45 divided by h, well, I know that that has to be eliminated. It has to be eliminated because when we equated our coefficients here, h had to be 4. And when I look at 45, 45 is not divisible by 4, so that would definitely rule this guy out. All right, so that should do it. That should take care of this factoring example from the SAT test.